Hello everyone, we are in my creative world, and in this video I'm going to set up the inventory system I showcased in my last video with a lot more detail. I'll try to keep it interesting for both the people who are just curious on how it works, as well as the people who might want to try and build it themselves. And I want to start right here. This thing here is just a decompiler, and it's not part of the system at all. This just lets me showcase the communication protocol, and when the system is complete you're not supposed to use the communication protocol manually at all, but there are some configurations that has to use it, and throughout this video I'm going to use it a lot just to showcase all of the different communication buses and how they work. So it's kind of important that you understand how it's all put together. This message here on the memory is a typical message you can see, and if I open it here, it's actually a composite value of 3 different values. The first one, read from the right to the left, is this. It's always the first 2 digits, and I reference this as the C value, and you'll see in the code as well it's a reference to the C value, the B value and the A value. And here is the hash for copper ingots, and this is just a number 50 and this is the number 32, and when the decompiler reads this message it decompiles it into the A value, which is the copper ingot hash, the B value 50 and the C value 32. And I want to showcase a couple of special cases just so that you really understand how it works. And the first thing is, if you want, for example, only the 50 on the B value and 0 on A and 0 on B, then the message would simply look like this. And the C value we have to type out. All the trailing zeros we need to type out. All the leading zeros we can drop. So this here is the 0 C value, and then the 50 B value, and then the A value, which isn't typed out but it's still there, which then gets read as 0. So now we only have 50 on the B value. And equally, if I want the B value to be empty, let's say I want 500 in the A value and the B value empty, and then a C value here, then you see the C value is 99, the B value is just zeros, but we still have to type it out, and the A value is 500. And correctly it gets read as 500, 0 and 99. And the last thing I want to mention is that negative values always follow the A value. So when I change this to a negative value, it would be read as negative 500 on the A value, but none of the other would change. And that is true even if I have minus 99. This read from the right, the C value is now 99, and because there is nothing more, the B value and the A value are 0. And because the negative sign always follows the A value, it is essentially just negative 0. And for the people who wants to build a system, I have 2 rules. And the first one is that you always need to use cleared chips. So if you have integrated circuit chips that's straight out of the electronics printer, that's all fine. If you want to reuse an old chip, it's very important that you clear all the memory on it, because there are so much of the code that needs it to be initialized like this. So that's very important if you reuse chips. And the second rule is you always have to turn things on. The first module I'm setting up here is the storage module, and I have 1 refrigerated vending machine and 1 silo, as well as 2 regular vending machines. And the system supports up to 99 of these devices in total, so you can continue this chain for a very long time if you wish. and you can use any of these 3 devices interchangeably in any amount you want. It's all up to how you set up the controllers. The devices just output into a chute that's collecting all the outputs, and that goes into first a stacker and then a sorter. And the left output on the sorter is the storage module output. And the right side just goes back into the storage module input, which continues down here. And each of the devices has their own sorter. And the vending machine requires a stacker on the input because it relies on having only max stacks in the silo. So this must be manually set up to have at least max stack size. The refrigerated vending machine has a built-in stacker, so you don't need a stacker on it. On the regular vending machines, you can choose to have a stacker and choose not to have a stacker. It all depends on what you want and what you are keeping in it. From my experience, it's beneficial to have a stacker, and here you can set the stack size to whatever you want. Just keep in mind, these stackers are not managed in any way, so if you have a half stack of something sitting in here, it's essentially invisible to the system. For the logic, we'll need 3 memories. We'll need the logic memory storage external, we need the logic memory storage internal, and the logic memory storage internal response. And then we'll need a IC that's the storage master. You only want one of these. And the main purpose of this IC is to coordinate the different storage controller we have over here, as well as manage the output stacker and the output sorter, so that we only get the exact required items and quantity out of the output. The pins on the storage master is first logic memory external, so the red one, and then logic memory internal, the white one, and then logic memory response, which is the blue one. Then we have the stacker and the sorter. The last pin is named logic memory router communication, and we don't need that to have a functional code, but we'll set that up when we get the router sorted. These 4 over here are the storage controllers. Each of them handles their own machine, sorter, and communicates with the master. So the pins here are the logic memory storage internal, the white one, and on D3 we have logic memory storage internal response, so the blue one. Then on D1 we have the sorter for this machine and the refrigerated vending machine on D2. So of course the other machines will have their own sorter and vending machine or sorter and silo, but the logic memory storage internal and the response memory is the same on all of them. I haven't turned these on yet, and that's because I want to show you something. They are all loaded with practically the same code. The 3 that's controlling a vending machine have exactly the same code, and the silo one is a bit different. So there is a separate silo code on this one. But if you look at the tooltip, it says state 0, and all of them say state 0. But when I turn them on, they will check in with the storage master and have an ID assigned. You see, this one gets the ID 1. And of course these IDs are unique. So this one gets 2, and this one gets 3, and this one gets 4. Now, when I'm talking about IDs here, and we'll later talk about addresses, just know that IDs and addresses are separate things. When I talk about IDs on these, think of them as local area IP address or something. Now that we have the logic up and running, we can essentially just start to fill the system with items. And I already have some prepared there. We have an egg, some steel ingots, iron, steel sheets, and some cable coil. And we'll see that everything ends up in the first vending machine, the refrigerated vending machine. And of course, that's not optimal that everything is in the refrigerated vending machine, but we haven't configured it yet, so the items will just take up the first spot they find. The storage system doesn't really care, it will output as normal without a problem, but with the setup we have here, it makes sense to set some sort of whitelisting or blacklisting on the different devices. And that's exactly what we're going to do. We are simply doing that by talking to the storage controllers through the logic memory storage internal. And on this bus there are 9 different functions, and we'll primarily focus on just a few of them. And by default they all start up with a blacklist on the items and an empty blacklist. So the first one, the refrigerated vending machine, we want it to, for example, set it to a whitelist and only whitelist eggs in this machine. And we do that by, first we need to know what the ID of the storage controller controlling the refrigerated vending machine is, and this guy says 1, so that's the address we need to talk to. And then we take our labeler, we go on the storage internal bus, and we need to set, we need to set the whitelist, so that's just a B value of 7, and then the ID of that IC, which is 01. That has now been accepted. The memory is already 0 again to acknowledge that the message is received. So this guy now has a whitelist, but there is no items on the whitelist, so it will not accept any items. To get it to accept eggs, we need to add to list and use the add to list command now that we have set a whitelist. And then we need to have the prefab hash for egg. And we need to set egg and then the command for add to list, which is b value 004, and then set the ID of the ship we want to add to, so that's 01, and now it is 0. So this has now accepted it, and we have now whitelisted only eggs on this. And we can now essentially just vend all of this out, including the egg. And the egg came back, and it's now only the egg there. And this guy is accepting everything else. But of course, in a refrigerated vending machine, we want all types of organics. And we can whitelist even whole classes of items. So the class code for plants are 11. So just as we added the egg, we can now also add the whole class of all plants. So we put in the class code for plants in the A value and the command for add to list 004, and then again we need to talk to the controller with ID 1. So now it has basically whitelisted eggs and all plants, and everything else will just get sent on to the next one. So on here, let's do, for example, ingots. Let's put a blacklist on this one, and let's blacklist ores in this one. So we can do that. By default it already has a blacklist, but we can also go through how to do that. This is a controller with ID 2. So, as I said, by default it should already have a blacklist, but just to show you, that's command number 8, and then we talk to ID 2, and we have now ensured that it has a blacklist. We can now blacklist the class of ore, which is 10. So we put in the class 10, and then we go 004. That's our command, the B value, and then we talk to ID 02. And we have now blacklist ores. And if I vend this out, I can vend out everything. Right, it has split up the ingots into 50s because of the stacker. So let's just do the ores. Everything else should end up in here anyway. So when we're just vending out here, they are arriving here, but the storage master recognizes that these are something that's not requested to be outputted, so they just get sorted back into the input. And there you have it. The ores are no longer accepted here. They end up here, and you might notice they skipped the silo, and that's because the silo only takes one type of item, so it essentially has by default an empty whitelist. So for the silo we need to tell it what it should have. And let's just add the iron ore on that. So we go iron ore, and the silo controller has the ID 3. So we add a whitelist. Well, it's already a whitelist and can't really change that on the silo, but we can add what the whitelisted item should be, and that is again the command 004. And then the ID of that controller, which is 03. And then we hit confirm. And it should now have whitelisted iron ore. So we can just vend out iron ore from this guy, and they should end up in the silo. There we go, 1 and 2. 2 stacks of iron ore now in the silo. Some of the functions on the internal bus are used primarily by the storage master to control the different controllers, but the functions 4, 5, 6, 7 and 8 are all part of the whitelisting or blacklisting of the items through the sorter. And one thing to notice is that if we, for example, had switched this guy over to a blacklist, that would not have cleared the list. So if we switch it over to a blacklist, it would have blacklisted eggs and plants. But there are functions for deleting from the list and clearing the list. And if you are wondering, if you're unsure if you have added an item, there is no problem to re-add it. It checks the list before it actually does anything. So if you try to add something that's already added, it won't do anything, and the same if you try to delete something that isn't there, it also won't do anything. On the external bus, there are pretty much only 2 functions, and the first one is just to query the quantity of items in the storage system as a whole. And if we do an example of that, I can ask it how many cable coils I have, and that's done by inserting the hash in the A value, and then I just have an empty B value and an empty C value, so both B and C value are empty. It will now tell me that there are 50 cables in the system. And if you noticed how fast that message took to come back, in that time that message has been read by the storage master, translated to a message on the storage internal, and then all of the controllers have read that internal message, counted up all their 100 slots, and reported back a quantity on the response one here. And if we look at this, you can see our quantity 50 is here, and this 04 is simply how many controllers has answered. So when the storage master sees that it has gotten 4 responses, it knows that it has gotten the full quantity and reports back to us on the storage external one. The second function is to request items to be ejected from the system, and we can do the same example with the cables. If I give it the cable hash and I give it the quantity I want it to eject, let's say 10 cables, so that's B values 10, and then I need to give it an address that isn't 0, and just 01 is just fine, so that's address 01 and a quantity of 10, and it will still respond. This time it will respond with a confirmation that we are actually getting 10, and we got 10 exactly out. So do you see that the storage system will always respond on the external bus, and the protocol here is that whoever asked has to clear the message. So when I manually inputted a command, then I have to clear the memory when I'm done. The next module we'll look at is the router, and the router is basically just a bunch of sorters, but the router is a very important part of the system because it makes sure of delivering all the items to the desired location. And this here is a router with 8 sorters, and you can have a lot more of them, or a lot fewer if you want, but this is just an example. And in this form here, this is the simplest form to build a router, and it just makes a loop, so the chutes just go through all the sorters in a big loop here. And you might notice that there are no inputs on it, and that's because the system doesn't really have any concept of start or finish on it, so you can basically put inputs anywhere you want. We can put inputs here. Let's see, inlet, and even right here in the middle. It really doesn't matter at all. Inlet, and that's pretty much it. You can set up the router differently and not have it in a big circle, but we'll look more on that later. Here I have 2 logic chips. Each of them has the exact same code. We haven't uploaded the code yet, but these are the router controllers, and you can theoretically have 99 of these ICs, and each of them can control up to 5 sorters. So pins D0, D1, D2, D3 and D4 are sorters. You do not have to use them all. Here I have not used D4, and on this one I have not used D1. It really doesn't matter. They don't have to come in any particular order or anything. On D5 we have the one and only memory for this system, and that's the logic memory router communication. That's this one. And to set up the system, again, as always, there are nothing to configure here, so we just export the code to both of them. And just as with the storage, take a note of the state on this, because when I turn them on, it will get an ID, the same system we used on the storage, sort of a local area ID if you'd like. And the same with this should now get ID 2. Yep. So we have the 2 IC control, 2 router controllers, one with state 1 and one with state 2, and that's the IDs on them. So if we try to give this system something now, let's see, let's give it some iron ore. Oh, I missed. There we go. So when the system is completely blank, it really doesn't know what to do with it, so it just gets passed around, and it will just go in a circle pretty much forever until we configure what the outputs are. So let me, I think I missed it. Or I deleted it. Either way. Let me patch that up. There we go. So to set up the system, we need to configure the routers so that it knows which addresses each of the sorters have. And we don't need to set up all of them at once. We can set up one by one. So if we do an example with this one, if I want an output here, I just need to decide an address I want this output to be, and it can be any 2-digit number or single-digit number. So all we do is that we need to know what the name of the sorter is. This is called sorter A, and then we need to figure out which router that's connected to, and it's connected to D0 right here. So to set an address for this one, I just talk on the router bus, and we need to talk to the router with ID 2. So we talk to router with ID 2, so we have 2 in the A value, and then we set the pin number, that's the B value, and because we are setting for pin 0, that's just zeros, and then we set the address on this, and that message is already absorbed. So this the router now knows that this is output 13, and if I try to give it the iron ore now, it will still not do anything. It will still just send it through in a loop, but we can now tell it where to send it. So if we go here, and this is done usually by the other ICs, but I just want to show you how it works. This is the hash for the iron ore, and we tell it the stack size, and it's a full stack, so it's 50, and then we tell it which output it should send it to. And so far we only have one, and that's number 13, so we'll give it that, and that message is already absorbed. And once the iron ore makes its way through, yeah, it pops out on number 13. And that message, that order is now done. So if I give it another iron ore, it will not get outputted. But the router can also be set up with a default delivery address, essentially a connection to storage for anything that's given to the router that isn't assigned to an output address. And that is done by assigning one of the sorters to the address 99. The address 99 is reserved for essentially to storage. So if we want to set up this sorter right here, this called the sorter E, if we want to set that to go to storage, we do it exactly the same as we did before, but we need to find the sorter E, and that's on this here. So this is router controller with ID 1, and we want to set the address for pin 0. So again, we talk to ID 1, is set for pin 0, and then we set the address 99. So 99 is associated with default output or storage in the routers. So when I give it the iron ore now, it doesn't have a delivery order for the iron ore, so it knows that there is nothing that requires this iron ore, so it will just output it to address 99. There we go. I have gone ahead and set the address 6 for this sorter, and this is the opposite side of the storage output, and those two are controlled by two different routers. So this guy is controlling the storage output, and this guy is controlling both of these, number 6 and number 13. And the thing I want to show you is that if we tell it that a stack of iron ore is coming, let's see, we need the hash for iron ore again. And if I tell it that I want a stack of 50 iron ore delivered to address 06, and I give it the iron ore now, it will get passed through here, and it should skip nicely over the storage output and get delivered out there. And that's because the router controller that's controlling these 4 sorters here, even though that controller isn't controlling the output the order is for, it knows that the other controller has an order for it, and that's why it decides to not output it to storage. So this way we can input items anywhere in the loop and always have it delivered where we want it to. And if we want it delivered to storage, we simply don't tell the router that we of any specific address. We can just dump items in it, and it will default to storage. The next thing I want to show you is redirecting, and this normally happens very fast by the other ICs, but I'll try to show you anyway. If we do the same thing we just did now, we tell it that we have a stack of 50 iron ore, but we want it delivered to address 42. Now address 42 doesn't exist, so when we give it the iron ore, it will just loop looking for address 42 that doesn't exist, and eventually the order would time out and it would end up in storage anyway. But what we could do is tell it to redirect all orders addressed to 42 and send it out somewhere else. And the way we do that is by telling it that we want to redirect address 42, and we can output all of the orders for 42 in address 13 instead. And the iron ore should end up in this output once it makes its way around. Yep, it did. So that's how we could redirect orders to a different place after the items has already entered the sorter. The last function on the routers is output range. And if we go ahead and set an address on one of these, let's see, this is called sorter B, so we'll put an address on sorter B, and that's here, so that's router ID 2 and pin number 1. So we go router address 2, pin number 1, and we set an address 20 on it. It would now output everything addressed to 20 in this chute here. But if we wanted to output a whole range, we can do essentially the same thing. We want to set a range for this sorter, and if we want to set a range of, for example, 10, we'll do almost the same thing. Let's see, we are talking to router ID 2, and we want to set the range for pins 1, and what we have to type in then is 11 in the B value instead, so that's 10 plus the pin number, so the pin number 1, but we are setting the range, so we're adding 10 to it, and then we can add the C value of 08, and that would output the next 8 addresses as well. So this is no longer just 20, it outputs 20 to 28. So this sorter will now output a whole range of addresses. So anything addressed to 20, 21 and everything up to 28 will be outputted here. And the reason for this function primarily is because with a lot of sorters the travel time gets really large. So if something is inputted here and should be outputted there, it would have to travel through the whole loop. And with 8 sorters that's not a big problem, but when you're closing in on 15, 20, 30 sorters, that's a long travel time. So with this output range and a bit clever addressing on the sorters, we could, for example, have shortcuts across the loop, and we could have all sorts of different setups. We could set up the sorter in different ways, like here I have two smaller loops, and the sorters that connects them just outputs the ranges that the other loop handles. That could work. Or we could set it up in a hub and spokes system, where you have a small number of central sorters, each outputting ranges that the spokes handles. Or you could take the time and set up the router in a tree structure, where this sorter outputs half in one side and half in the other, and then these do quarters and so on. But to keep it simple, we are sticking with a big circle. I have rebuilt the router in preparation for what we are going to build next. But it's essentially exactly the same thing. You notice that it's still just one big circle. And because we now have 14 sorters, I need 3 router controllers, but the process is exactly the same. I have given most of them addresses already, and this one on the end here is address 99, aka storage system, and I wanted to show you how we connect that up. And the first thing is we need to shoot it over. So this will be the output from the router. So it will go to the input on the storage system, and vice versa. We need the output from the storage system to go to the just anywhere input into the router. And I've already prepared a junction right here. And just like that, we have connected the router to the storage system with chutes. And we also have to set the last pin on the storage master that we skipped earlier. And that's, of course, is the logic memory router communication bus, which, of course, is this yellow one. So if we order something from the storage system now, let's do an example. Iron ore, always perfect. And let's order iron ore, and let's order only 10. And let's send it to address 03. And then we get a message back that 10 is confirmed and the ore is on the way. And now the storage system has already alerted the router that the stack of iron ore is arriving, and it's delivered out on address 03. And the next piece of logic we are setting up is an IC called the Crafter Master. And while this IC isn't terribly exciting, it does introduce 2 new memories. It's the logic memory central order and the logic memory crafter internal. And the pins on it is essentially both these two. On D0 we have logic memory central order, so this one. On D2 we have the logic memory crafter internal, this one. And on D1 we have the logic memory storage external. So that's the red one, the external bus on the storage. And what this IC does is, as I said, not super exciting, but it gives us the ability to have one place to order from. So that's the central order. And this guy just reads that memory constantly, and as soon as something comes on it, it takes it off and puts it in a queue. And it will redirect that order and coordinate between the storage and the crafters, so that anything you already have will be delivered from storage, and anything that must be made will be made from the crafters. And when I'm talking about crafters, you are probably thinking about the autolathe, the pipe bender, electronics printer, and perhaps even the packing machine and the automated oven. But the crafter I'm talking about is a more general term, and it's pretty much any machine that can make anything. So that would include the furnace is in this sense a crafter, because it can take some inputs and create something out of it. And in that sense also a Harvey is a crafter, because it can also craft something. And even the Amy bot is a crafter because it can produce something on demand. And the first crafter we are setting up is the furnace. Here we have an IC called the Crafter Controller Furnace. We haven't set up the code yet, and that's because I want to show you how that's done. It's just important to remember that this isn't actually controlling the furnace in any sort of way. It's more of an interface between the inventory system and the actual furnace controller. And I have my furnace controller set up here, but it's compatible with most furnace controllers. I know that a lot of people love to make their own furnace controllers, so I've tried to make it as compatible with other systems as I could. On the computer here, the first thing we need to do is to look up the Crafter Controller Furnace, but you can see here that it says requires stack loader, and you can see most of the Crafter controllers needs that stack loader, and it's the same stack loader for all of them. It's just one code called the stack loader, and that looks like this. So this contains all the information that all the different crafters need. And when we upload that to the IC and we turn it on, it will automatically shut itself off after a tick or two, like it did now. And that's how we know that it's done. So now that that's done, we can upload the actual code to it. And that's right here. And it's one important thing we need to set up here. And that's all the way on the top. And this is true for all the Crafter controllers, and that's the address. You see, it doesn't know which address it has. It doesn't know which address it has, and that address is simply the address we have chosen in the router that outputs into the furnace. So for us, that's address 1. So we just need to set the address 1 right there. And the pins on the IC is on D0, we have the logic memory crafter internal, which is the purple one we looked at over there. D1 is the logic memory storage, that's the storage external bus, the red one we have used quite a few times now. And D2 is the logic memory router, so that's the yellow one the routers use. And on D3 we have one that's called LMD set recipe, and that's essentially where the Crafter Controller Furnace sets what recipe the furnace is supposed to deliver. For my furnace, you can use the IC library and just paste, and it will just paste the hash there, and that will automatically switch the library over, and that will the furnace setup will take care of the rest. If you are using a different furnace setup, then you can also put a dial here, and it will set the correct dial setting for that furnace. And the last one is just the advanced furnace on D4, so that it can read the output slot. So this pin right here that sets the recipe, if you are not using my furnace setup, if you're using a dial controlled furnace setup, then you can set the dial here, and the correct dial setting isn't necessarily what's already in there. And let's jump back to the stack loader, because in the stack loader you can see that here is all the different furnace recipes. So here is also the dial setting, so dial setting for Vaspaloy, the dial setting for Stellite, the dial setting for Inconel, and so on. So if you're using a dial operated furnace and this is not the correct dial settings, you have to change that here before you upload the stack loader. These numbers here are for Kausar Evils' furnace setup, so if you're using his, then this should be compatible straight out of the box. The only requirements for the furnace setup is that it will automatically set the temperature and pressure and output the ingots, pull the lever here when it's done. Let's test it out. Let's place an order here for an ingot, And we can use Electrum. I have given the storage system some gold and silver ore. So we can place an order for Electrum, and let's do an arbitrary number. Let's do 17 Electrum, and then have it delivered to address 03. That message is read by this crafter master. The crafter master will then ask the storage system if it has any Electrum, and the storage system will answer and say no, I have nothing. So the crafter master gives that order over to the crafter internal bus, where this guy picks it up, and you can see it has already switched the furnace over, and it has already gotten the gold. This guy will then go through the ingredients and order up everything it needs from the storage system directly, and we have received 18 Electrum. But this thing isn't a stupid little thing either. Because it has connection directly with the storage system, it also has access to all the information the storage system has. And I have taken out all the steel ingots, and I have given it some coal, but only 2 coal. And we know that it only has 2 coal, but the furnace controller will have to figure that out itself. So if we place an order for steel, let's see. If we place an order for steel and we do 50 steel and deliver to address 03, then this guy will eventually figure out it should make steel. There we go. And it will start to order the ingredients for the steel. And I saw the coal disappearing and the iron just went off. So, because when we are making ingots, it's really important that we have exact ratios. And our steel is coming over here. And we only got 8 steel, but that's exactly the maximum we could have got with only 2 coal. So this guy, because it's so important that it's perfect ratios, this guy will talk to the storage system before it orders anything. And it will ask it what the quantity is on all the ingredients it needs before anything is actually dispatched to the furnace. Now we have everything we need to set up the actual crafting machines. And the electronics printer and the pipe bender, the autolate, security printer, tool manufacturing, anything that wants regular ingots will use the crafter controller general, while the automated oven and the packing machine uses the crafter controller food. But the only difference between those 2 codes is the type name they are looking for. So on the pins they are exactly the same. On D1 it's logic memory crafter internal, so that's the purple one we have over here. On D1 we have the logic memory router, that's the yellow one. We have D2 central order, that's the pink one. And then we have the machine, so that's the specific machine this is controlling, and the stacker belonging to the machine, as well as the button. And the only thing that's mandatory on this is the machine and the stacker. All the other 4 are optional, and it will give different behavior depending on what you choose. Like here you can see I have set no device on the router, and that's because this machine outputs directly here. On the pipe bender it outputs into the router, so here we need the router memory. When they output directly into the room, there are no point in alerting the router of something because you're not outputting into the router. You can also choose to not have the internal crafter internal bus, and if you don't set that, then the controller will of course not take any orders from the system. You can only get it to make stuff by pressing the button. You can also choose to not have the central order. That will remove the ability to order ingots from the system, but it's all up to you. You can also choose to not have the button. If you choose to not have the button, then it will only be useful for taking orders from the system. And in the code there are also a machine address, so that's the address we have set in the router that ends up in the machine. But we have also a second line that called the delivery address. And for the machines that output directly here, then that address has no meaning. But for the machines that output back into the router, that address is where it should get delivered to. You can also set up multiple of the same type of machine. I've set up 2 autolates and it will work perfectly fine with both of them, and you can both order from buttons and from the memory, and they will both get to work. This is essentially the core of the system, and you can set this up however you like. And even though there are a lot more code in the collection I have linked below, the rest of the code is essentially just tack-on modules that connects to these already established communication buses. And that's why I have made a code that's called the API code example. So this code here is for you to use. It's heavily commented so that you understand what everything does. And we have basically 2 examples. We have a contact storage example and a place order example. So this example here is used on most of the communication buses. The only difference on the top one is that the storage responds, so we have to deal with the respond. But I would really like it if people who build it try to make their own modules to it. So that's why I have released this code as well, so that you can make your own code to fit into the system. And because I want to invite people to make their own modules to the system, and because this video is already getting very long and I have already done a lot of it in my previous video, I won't go through all the small details, but there is one thing I want to go through, and that's the tracker. So if you saw my previous video, you know the system that tracks me around the base and makes sure that it gets delivered to wherever I am. And you have already seen me set up a delivery zone, but I'll show it here real quick. I have set up this sorter here to address 40, and if I have this tracker, it has a tracker config. So we set the address 40, we want to configure the address 40, and we go and turn our air off here and our air off on the other side. We have made a boundary box so that the tracker now knows that we are in delivery zone with address 40. But the thing I wanted to show you is that in the code we have this line, define tracker address 98, and this is commented as a non-existing address. So the way it works to have the tracker follow you around and make sure that the items get delivered to you is to just set on the storage devices or on the crafting machines. I mean, we set the let's see, when we set the delivery address here, if we set that to 98, the same address we had on the tracker, they will essentially just output into the router that whatever item is addressed to 98. And if you remember from the router part of this video, you know that if we have an item that's passing through here addressed to a non-existing address, it won't output anywhere. And the tracker, all the tracker does essentially is just to use the redirect function for the routers to route that non-existing address 98 to wherever I am currently at, and currently I'm closest to output 40. So if you want items to be sent to wherever you are, you need to just coordinate which address you want that to be. So a non-existing address, for example, address 98, and the tracker will simply redirect whatever is addressed to that number to wherever you are. With a system this configurable and complicated, bugs do happen, and I couldn't possibly test every possible setup, so just know that bugs will definitely happen, but all the ICs are fitted with timeouts, so if they will most likely self-detect that a problem occurs and just time themselves out and reset to a normal setup. So if something goes wrong, the first step is to just wait it out and see what happens. Most of the timeouts are 2 to 3 minutes, and if that doesn't solve it, the main way to clean the system is just to pull the ICs out of the socket and put them back in. That will normally reset them back to a safe state, and make sure that all the memories are empty. They should always be empty. So that's pretty much how far I'll go in this video. I hope that you have a better understanding of how the system works. For the people that's more interested and want to look into the code, I have a collection linked down below. I will also have released, probably not this world, but at least the Vulkan world, where most of it is already set up, so you can have a look at that. If you have questions or problems, you can contact me. You can either comment on Steam Workshop pages, or better yet, you can find me in the Stationeers Discord usually, and you can just send me a private message there, and I'll try to help as much as I can. Just know that this is not a super simple system to set up, and it's not very beginner friendly, so if you are brand new at Stationeers, I would probably hold off on it. But anyway, thanks for watching, and I hope you like it.